So I will, for those of you that are somewhat new to VDC, I will briefly introduce VDC, but also go a little bit into the history, how I experienced its genesis, and then share with you my top 10 list of what I see successful companies doing with respect to VDC. It'd be interesting to see, compare that list with other practitioners. I'm curious what others would have put on the list. It's always risky when you put this kind of list together, but unless you put it out there, you'll never know what the others think. So let's jump into the slides. So this was called the VDC 101. I guess it's a bit of a crash course in VDC. Many days I'm very proud that I'm part of the construction industry because we create the fixed physical wealth of societies that really enable, pretty much most of our economic, social lives. But the economic, environmental, and social costs are too high. So other days I'm not so proud to be part of the construction industry. Well, it's kind of fitting that COP26 is going on right now. So we certainly need to do a better job in that respect, but also socially and economically. Still, many project teams are able to create high-performing buildings, like the Gigafactory. I think it was a remarkable achievement in terms of the speed with which it is designed and built, or this office building in Seattle that is water and energy positive, sustainable multifamily housing project that also turned into the largest money-making real estate transaction in Arizona in history, or in my native Switzerland, the longest, I think, still rail tunnel. I feel like one of these days Norway is going to beat that, or maybe Japan. But so we see many high-performing buildings, and of course there's many more. But we need many, many, many more than we are able to do. What are, in my mind, the two main issues with the lack of really high-performing building? I think one is often surprisingly a limited vision, even though we're talking about a very large expenditure for most building owners and infrastructure owners. It's surprising how limited the vision is for the performance of the building, and how little of that is actually shared. At least that's my experience around the world. Of course, there are exceptions. And then the other one is that disciplines join projects sequentially, which is kind of crazy because all of them contribute to the success of projects, but by bringing them in sequentially, they are straitjacketed by the decisions that happened before them without their input. And on top of it, most of those disciplines work in their information silos. I think those are a couple of the main reasons why we have not as many high-performing buildings than we need to have. Again, I'm also curious here, what do you think are the main reasons? So a little bit of a reflection back when after I graduated and worked in industry as a young engineer, I thought that constructors, would give proactive input to design, that designers created designs that can be built and constructors build what is designed, that information is available when you need it, and information does not conflict, and that the whole team is pursuing the same goals. This was not the case on this project that I had the pleasure of working on. We got the project built, so that was good, and there was a new bridge that connected two parts of Rhode Island in a much more straightforward and safe way. But we did not have the same goals across the project team. We certainly did not have information readily available. We spent some days, 75% of the time, looking for the right information. And it certainly could not, the structure could not be built as designed. And so it required an extensive redesign period. So this was a wake-up call for me that got me back to the university, where I had the luck, I guess, at Stanford to walk into a set of professors that had this vision in around 1986, 87. Paraphrasing, they said something like this: object-oriented programming will enable the modeling and simulation of built facilities so that design, construction, facility management, and other concerns can be understood simultaneously, while there is still a high influence on project outcomes, meaning early. So this was Stanford professors I had at the time, their collective vision. Then they also reflected, for this to really happen, we need to formalize knowledge from all phases of a building project so that it can be digitalized. And we need to reorganize project teams to integrate the know-how. Sorry, somehow something got lost there. So, and of course, we see this now actually happening, right? We see increasingly knowledge being from different phases of buildings or bridges life cycle formalized so that it can be shared across all participants. And we see a reorganization of the industry to bring the know-how to the table when it matters most simultaneously. So a few years later, as we saw the emergence of lean methods, BIM, among other things, collaboration methods, we felt that what was needed was a management method to leverage these advancements. And so that's when we coined the term virtual design and construction. We wanted it to sound familiar and focused on design and construction. Of course, it includes other phases of a project's life cycle, but also new at the time, which was virtual. But also the virtual really opened up these opportunities for collaboration. So we defined VDC as the management of integrated multidisciplinary performance models of design construction projects, including the product, work processes, and the organization of the design, construction, operation team in order to support explicit and public business objectives. So I think those familiar with VDC, you can see the VDC elements in here. I think we're still working on implementing this vision because we still need to develop, we have many performance models, but we still need to develop many performance models. Especially work processes in the organization, we have more of them for the product, for example, for structural engineering, or in some cases for cost estimating and so on. And we need to still also work more on creating explicit and public business objectives, as you will also see. And we have a ways to go of really creating this multidisciplinary modeling environment. We have made lots of progress, but I think we can still do better. But this was our original definition. I think still is somewhat an aspirational definition for VDC. And I have to thank John Koons at SciFi and also Todd Zabel and Roberto Arbulu, industry collaborators from Strategic Project Solutions, for the collaboration at the time that put this definition together. So for those of you familiar with VDC, you're quite familiar with this next segment, but I was also told I should have a quick summary of what VDC is, how I would summarize it, so that hopefully the rest of the presentation makes sense to all. So in a nutshell, I explain VDC as follows. This is a phrase I hear a lot, Martin, yeah, because people know I have fun with automating things. And so then I often hear, well, it's all about having the right people. And yes, of course, it's the people that make the project happen. But, right, if I have a choice between just having the right people and having the right people with good tools, I'm going to choose the right people with good tools. In my experience, they can outperform a team of just the right people. So, but we can only do so much without tools. And a particularly important tool, there's others as you will see, but the particularly important one is BIM, because it creates a digital replica of what we are getting paid for. If you are in a design construction phase or design or construction side of things, but even as a client, you're probably working for a client that needs buildings or infrastructure. And we all have a job because somebody needs a building, like here, this hospital. And we only get paid when we put that hospital in place. So, and I know many of you, I'm sure, are regularly now modeling everything in BIM, but in some places of the world, it's still something that gets discussed, which is strange to me, that in 2021, we still discuss whether we should use a BIM to represent the thing that we are selling or adding, how we adding value. But the best people and tools will not achieve much, right, if they're working in a poor workflow. Great tools, great people, and we have an awful workflow. Well, that's not going to get us very far. Maybe we're going to get somewhere where we shouldn't go faster, or maybe that's even worse than to have great people and tools. So we need to really define these workflows together with everybody else we're working with on projects, because the kinds of people that I know in our industry are not so good at following other people's directions. They are entrepreneurial, enthusiastic, self-made kind of people, and they prefer to take action. And so unless we define workflows together, we are all going to go in different directions. I'm sure you have experienced that. But again, the best people, tools, and processes will not matter unless they're focusing on the right objectives. So if you focus on the wrong thing, then yikes, right? You are really wasteful. And that means we have to establish and track project and client objectives. What do we want to achieve? And Tulika mentioned that I've had the pleasure of working with thousands of professionals around the world on VDC. And the definition of these objectives has been the hardest thing for the professionals I work with to do on their projects. So voila, this is VDC, but we bring people together with modern collaboration methods. We call it integrated concurrent engineering, as opposed to the simultaneous, sequential siloed engineering that we still sadly see too often. Supported by building information modeling and other information management tools. Basically, you can think of it as good information. With attention to project and production management. You're producing a digital building and a real building. We're producing experiences for all involved in the design, construction, and use phases. And to achieve project and client objectives, with project objective being those objectives that you can measure at the end of the design construction phase, and client objectives being those that you can measure during the use phase of a structure. So this is VDC, or summed up in another way, VDC combines quantified objectives, timely and real collaboration, good information, and clear processes. Or simply put, VDC establishes what you want to achieve, with whom and how. Connecting it to digitalization, which is a big word, a big emphasis in many organizations these days. I see VDC fitting as follows, right? We want results. We need, of course, a project team, the right people to produce those results, supported by data and process. And they really inextricably linked, right? If you don't know what results you want, the project team can't really be successful. It's kind of obvious. If you have the wrong project team, they will have the wrong data or the wrong process or both, and so forth. So you cannot really take one of these out and still get 75%. It's not how it works. Okay, so I promised my top 10 list of what sort of reflecting on my experiences with many professionals and companies around the world. Thought, okay, what do the best-in-class companies do to be successful with VDC? First of all, they insist on defining clear client and project objectives for each project. They assemble the project team with the expertise to achieve the objectives from the start of the project. They don't go back to like, this is what we did last time. No, this project has these objectives, therefore need this expertise to achieve it. They collaboratively establish workflows to be followed. You already saw that. They use the generation of digital models as the key mechanism to build trust, mutual support, and proactive problem identification and solving before building the project physically. There's really this two-way street that I see successful project teams use. They go rapidly from a concept BIM to a fabrication level BIM. Don't pave the cow paths of incrementally adding information. In my experience, not necessary. Use all the VDC elements together, so they get out of lean, BIM, and other silos. They set up digital information flows and use the generation of digital information flows to get everyone out of the discipline function or phase silos. They create digital feedback loops for particularly important project and production objectives. They check the accuracy of critical predictions, including reasons for deviations, and improve the predictions through a combination of data-driven, experience-driven methods. So they can continuously improve their interaction with the tools they use, and they automate something new each year. It could be more frequent, but I would say at least each year. So let me illustrate these. I'll have to go quite fast. So defining clear client and project objectives for each project. Typically people tell me, yeah, that's what we do all the time. And then I say, show me. And then I see something like this. Well, we need a flexible building. Oh, we want to have good quality. Okay, that's nice, but how do you know that you really have achieved it? So we need to define them in a much more specific way, something like this. Like, what does flexibility mean? A floor can be reconfigured from single offices to open area in 1 week. You might think that's not a good way of defining flexibility, or a week is too long or too short, whatever. Fine, that's the point. Now we can have a discussion and engagement, and we can figure out what it is we really want to achieve. Or in terms of quality, we could define it as fewer than 1% of the construction work hours will be spent on rework, or 98% of the inspections are passed the first time. So it's fine to have the sort of broad, aspirations and goals, but you should also quantify them to really show what you mean. And you should insist that those be quantified. This is like, if you go in an Uber and say, take me somewhere interesting. Okay, that could be kind of fun, but it's not, what will most likely get us where we really need to go. Assemble a project team with the expertise to achieve the objectives from the start of the project. As Henry Ford said, working together is success. So I found this quote from Jim Carroll from the Washington Group quite relevant here. He says, an owner needs to decide what it's buying, a product or the services of a team to solve a problem that no one completely understands and that keeps changing. I think too many times we think we buy a product and we actually have to figure out a particular problem. And so there, if you're buying a product, fine. There's certainly a market for that, and many companies are very successful with that. But many projects are not at that level, or for various reasons. And then it's kind of crazy to have this product buying approach when in fact you're needing a team that really helps you figure out the problem and solve it. So this is the signing of the first IPD contract for the Sutter Health Custer Valley project. So collaboratively establish a workflows to be followed, ideally from workflow templates, so you don't have to reinvent the wheel again and again. And I really like this quote from Deming here, right? If you can't describe what you're doing as a process, you don't know what you're doing. And next to defining clear client objectives and project objectives, really mapping out the process, I found is also quite challenging, but really looking forward to the other speakers and see what they share in respect to process mapping. Obviously, this is now digitalized in most organizations, but we see, of course, many project teams coming together and defining their workflows for the whole project, for the next 100 days, for the next week, together, so that there's a better chance of actually sticking to them and understanding them. Because right process is really in the middle between data and results, in terms of what people need to be successful. Use the generation of digital models as the key mechanism to build trust, mutual support, and proactive problem identification and solving before building the project physically. Right? We need the right team, the right people to create good information, but then when we have good information, that actually further enables the right team to be successful. So I've seen this really mutually enforcing relationship. I also hear often, yeah, it's all about the trust. Okay, then what is your strategy to build trust? Of course, we can do many team building type of things, and I'm not saying you should not. But in terms of the actual work, the best way that I've seen project teams build trust is when they can see rapidly that everybody is doing what they agreed to do, following the process that was just established. And for that, having good information that is easily visually accessible is super important. We saw this on this wastewater treatment plant in San Francisco, where during the pandemic, they designed and built, started building this very large, the largest wastewater treatment plant in San Francisco. And because they were able to they shipped the VR glasses to everybody, and then they were, or headsets, and they were able to meet right frequently and work out all kinds of issues. And people could see, oh, I had this comment, oh, it was fixed, great, everybody's on the same page, like here in terms of the maintainability of a mechanical process room, or just a design review in VR to make sure, again, everybody's on the same page. But I'm sure many of you have used tools like this. But this really built, even when the teams were distributed, trust very rapidly on projects. And that further makes the information get better, which further builds more trust. I've also seen successful project teams go very rapidly from a concept BIM to a fabrication level BIM, because once you have agreed on the concept BIM, because you've had the right people there and the right workflow, then the next stage should be, let's figure out how to build it. Can we really build it? Which you really only see when you have a fabrication level BIM. This is really was led, as I mentioned at the beginning, to the success of the Gigafactory, the first Gigafactory, but now others have been built also very fast, where 3.5 million square feet were designed and built, ready for tool install by Tesla in 10 months. So Tesla kind of freaked out when they were super successful with, well, excited, but then I think also some people freaked out a bit in terms of meeting the orders when they ordered, when 400,000 cars got ordered in one day, Model 3. On day 48, after that, most of the steel was ordered because enough design had been done. So the design strategy was very much one of ensuring, right, decoupling the complex lateral system design from the heavy gravity design, which could be done very quickly. That required some innovative structural system, but that's what made this possible. So that the process was fit with the project objectives, as you can see, and the team was put together to achieve those project objectives, back to some earlier points. They broke ground on day 86, erected first steel on day 116, started the MEP design on day 155, and day 310 turned it over to the client 10 months after the successful launch day for the Model 3. So this was really made possible because they worked essentially in a fabrication level BIM, except for the first few weeks. So that everybody was on the same page. There was no time to waste with coordination that might be obsolete because details were added, would be added later. And then it was very clear what needed to be produced by whom, fabricated, etc. So this was all put together in this big room right at the project site. So the latency in terms of getting answers to any kind of questions from anybody was extremely short. But that was also supported a generation of good information and trust, but also likewise, that enabled these short latencies. Here a picture of the completion of the steel structure for one of the buildings with this innovative lateral system that opened up most of the bays for Tesla to enter the building because they had not finished the design of the process, so they didn't really know where they would have to enter the building, among many other challenges. So use all the VDC elements together, get out of Lean, BIM, and other silos. As you know, I'm a big fan of BIM. I'm also a big fan of Lean. I think that together, the two work dramatically better than just by themselves. And there's other silos in terms of partnering, collaboration, etc. that we see. But on a project, you have to do all of these things. So use all of them. This was really shown, the success of this was really shown by Kosapi and the project team for the Pan Am Games in Lima a few years ago, where they embarked on the project with the full intent to use all the VDC elements together because they felt that was the biggest chance for success. For various reasons, they only had 18 months to design and build the major sports venues. And of course, you couldn't be late. This had to be world-class facilities. So you're building a level of quality that hadn't been built in that location at a speed that really had never been done before either. I'm not sure even outside of Lima. So the project team, right? This gives you a sense of the whole scope that they were putting together in 18 months of design and construction. So they used integrated concurrent engineering sessions frequently. Most importantly, in 10 weeks in the major part of the design phase, they had a 2-hour ICE session each day where they've solved 15 critical issues each day, with typically 10 members involved in each of these sessions. So very rapid identification of issues and solving of issues, because you don't have time for things to linger. BIM, everything was of course in the BIM. They had overall 60 models, eventually at level of detail or MMI 400, solving 3,000 issues during construction with no construction, during design with no construction impact. They had 10 BIM uses implemented and 90% of the project staff were working with BIM. They codefined processes and procedures, for example, on how to work collaboratively, among many other, so that all the participants would be aligned. And this was involved, the major parties for the project were working in Peru and in the UK. So it also involved this collaboration over distance. So I think, yeah, you can imagine what this looks like. It's just some illustrations from this effort of codefining and then executing these processes. So again, if you take one of those elements out, you're not likely to be successful in the project. So using all of the elements of VDC together, really, at least that project in felt led to their success. Set up digital information flows and use the generation of digital information flows to get everyone out of the discipline function or phase silos. We were able to study with a major engineering firm in San Francisco a few years ago, how much time they spend where do engineers spend their time? And they found that 36% of their time is spent actually doing engineering. 8% was spent planning work. So that's all pretty good. Probably two things you'd expect an engineering company to do. The remaining 54% was spent managing information, finding it, organizing it, and so on, which is kind of a crazy amount. You would expect some time, but that was a bit high than people had expected, because really people were stuck in their discipline silos and phase silos. So when I think of information in the context of a project, I really always have in mind this quote from one of my former PhD students, Kathleen Liston, who said one day on a project, in a project team meeting in frustration, are you working for the information or is the information working for you? Now, I'll share an example later where we see the difference between information working for you or you working for the information. So to get people out of discipline silos and create information, these digital information flows, you don't have to have a massive projects to do this. You might say, yeah, that's all good for big projects. We were able to see this actually also many years ago one of our graduate students who came from a construction family, and she was wondering whether BIM-based quantity takeoff would actually pay off for the kinds of small projects her family was doing also in Peru. So she got data on how much time it takes to do a budget on a small retail project. So that was 41 hours. So she then said, okay, let me build a BIM and then use that for quantity takeoff. And so overall, she used 53 hours, so 12 more, but 32 of those hours are work that she wouldn't have to do on a second project. So on the second project, you would save half the effort in terms of creating a budget for the project. On top of it, she found mistakes and change orders totaling 10% of project budget. So that is also quite well, that would have increased the profit margin of the company quite significantly. So I think this is well within our reach today to create these digital information flows and connect different disciplines. Create digital feedback loops for particularly important project and production objectives. We have to also not only say what we want, we have to also check whether we get that or getting what we want. And now we can really collect data in many, many ways. One that I have come to really enjoy is a crane hook, an IoT crane hook from Versatile. I mean, of course, there's other methods as well, but this gives you data every second of what the crane is doing. This helped us learn on this parking garage project with Clark Pacific, what is the variability of installation work? This is data we typically lack. We talk about variability as a critical sort of issue to deal with, but we typically don't have a really carefully collected data. And here we saw, for example, for the shear walls on the ground floor, that there was a difference of 5x between the fastest shear wall and the slowest shear wall. Reason being tolerance of the cast in place rebar. But seeing where you have the issues and why you have the issues and what is the range of issues as expressed by these variability in installation time was super helpful for the project team. If you think that was just the shear walls on the ground floor, that really continued for the rest of the project in terms of range of installation durations for all kinds of components. Here I'm just showing the beam, the different beam conditions and the average and typical range of installation times. So you can see that even for a tight range, it goes from about 3 to 5 minutes, which of course over the course of the whole project with thousands of elements adds up. So we're for the first time able to really learn the cycle times we have, and then also see where on the project you have a high error between your prediction and your actual installation time. And using the actual data, we could then tell the project team, hey, if you're happy with the 90% likelihood of meeting schedule, you could actually install 7 more parts, per day. You could, of course, live on a riskier level or less risky level. But for the first time, you're having data to actually size, understand this and also size buffers. And we see increasingly, of course, data collection on sites, for example, with tools like Spot, but again, many others, which streamlines not only the management on site, but also off-site activities, like here, payment cycle, processing of payment applications being reduced significantly by Swinnerton, by being able to collect this consistent data set every day at the same way, which starts to get us to a place where the information is working for us instead of us working for the information. Then check the accuracy of critical predictions, including reasons for deviations, improve the predictions through a combination of data-driven and experience-driven methods. If we actually really look how good our predictions are, especially the first predictions, which are really the most important ones, we see significant discrepancies. For example, for energy performance of buildings, that is well-documented range, right? You can see in the chart on the right, if every prediction was, where it should be, it would be on the horizontal line. But you can see for many types of buildings, predictions vary quite widely, as documented by many papers. On the left are buildings from a major owner-operator in terms of comparing, again, the actual operation, which is the red bars with predictions from design assumptions and then from simulation. So we have a way to go to make our predictions better. And that's where digitalization can really help, because it helps us get a description of what's happening, why is this happening. This is much more challenging, what will happen, and what should be done. To connect this to sort of everyday examples and to give us a mindset of what we might want to move towards in construction, we can take an example of driving, right? What is happening? You can look at a map, and that's where, right, we are now used for the information to work for us. We used to have to work for this information by looking at finding maps, looking at studying the maps, etc. And now this is sort of very natural for us, or very easy for us, right? Because the information is actually working for us. And we can understand why does it take long to get somewhere. We can get a prediction. If you leave now, that's how long it takes. If you leave later, that's how long it'll take. Eventually, you know, and obviously many efforts going here, then the car will just take us. And so similarly, I think we are on a trajectory on our projects to improve our predictions, which is essential to eventually create some autonomy and explain what's going on. And finally, I think we need to achieve so many more things to get more high-performing projects that we need to start to automate things we know how to do. So we don't have to do them, and we can do other things that matter at least as much or more. And so we saw this, for example, in a collaboration with Mortensen, the leading wind farm builder in the United States, where they basically said, we basically know how to create the construction information for a wind farm. By doing so digitally, we can now start to optimize the whole wind farm, not just for electricity production, but also for construction cost, and see the trade-offs. So we were able to do this on a project in Texas. You can see here the wind farm. This was retrospective, so that's why we know how much money could have been saved. But here you see the wind farm towers that they designed, the blue dots, with then the corresponding network of roads and distribution lines and collection lines. The optimized wind farm would have looked like this. Basically, all the yellow areas are areas where you wouldn't have needed the land. So saving quite a bit on the collection and road system and in negotiations with landowners. In numbers, they could have built by using, right, the optimization and trade-off, understanding the trade-offs between generating electricity and construction cost. They could have built the same wind farm with 10% less land, 8% less capital expenditure, which is not unattractive, right? So by automating something, team can again do significantly more. So this is my top 10 list of what I see world best-in-class companies do to be successful with VDC. And hopefully this talk has given you background of VDC, where we came from, a quick introduction to VDC, and then list a few items that you feel like, okay, yes, we can do that. A bit of a checklist if you're already doing those things, and maybe some aspirations of what to do next.
Thank you so much, Martin. This was perfectly on time, but we do have time maybe for one question, if there is any from the audience.
There's no question from the audience, but there's one here, Martin. You said that one of the most difficult things in the project was to define client objectives or project objectives. You know, like, could you explain why this is so difficult? Because this is what the client actually, he has to say what he wants with the project. What is it that makes it so difficult to define it?
I'd love to hear others' reflections on this too. in my mind, it's two things. One is often, especially large building owner operators, they have many stakeholders, internal stakeholders and external stakeholders they have to satisfy, and bringing all of them together and having them articulate what would a great building or a great road really be or do is actually quite hard. So that's one. The other is, it's a bit like, if you ask me to define, what is the great Christmas present for my wife, difficult to say, just like that, right? What is, but when I see some examples, then I can do that. So the client objective definition is it should be a bit of an iterative process in my experience. Put some objectives out there, then I realize you typically have to see what you can get, what is possible, and then you can refine these objectives. I don't know, what in your experience, Katrin, do those resonate, or do you see other challenges?
In my experience, it's often they put the goal, but quantifying it is the difficult thing. To have it like with numbers, and that the goal is clear enough. It's often phrased with better, bigger, best, less, reduced, but they don't quantify it well enough to be able to point at the goal, work towards it. That I would say that I find often with clients' objective, the list.
When you find that the cost-focused objectives get quantified more, but the value-focused, really the reasons why a building or road is built, there we find the challenges.
Yes.
So if somebody wants to do a PhD,
on client objectives?
Yeah. There's many other topics too, as you could see. But I think we probably need to move on, right? To stay on schedule, sort of.
Yes, I was just about to jump in. Thank you so much, Martin.